Silver is the nervous system of modern civilization. But beneath the surface, time is running out. By 2035, global digital infrastructure will demand far more highly conductive metals than the Earth can physically yield. You're watching Next Move Strategy Consulting, where we uncover the stories behind the world's fastest growing markets and technologies. In this episode, we examine how advanced recycling technologies are transforming silver recovery from electronic waste, solar panels, and industrial materials. In early 2026, Umicore reported a surprisingly strong financial start for the year, driven by record secondary recovery yields. This signals that the recycling sector is quietly absorbing the shock of primary supply deficits. Strategic alliances are shifting rapidly. Heraeus Precious Metals just signed a sweeping memorandum of understanding with VS Particle, pushing the boundaries of nanoscale material synthesis for next-generation catalyst applications, proving that secondary metals can outperform primary equivalents. The engineering bottleneck of e-waste is finally cracking. As reported by PV Magazine, researchers at the University of Newcastle have developed a groundbreaking separation technique. By applying the same crushing and flotation principles used in traditional mineral processing, the process achieves a staggering 97% silver recovery rate directly from end-of-life photovoltaic panels. Infrastructure is scaling to match this. Aurubis officially inaugurated a globally one-of-a-kind recycling plant in Hamburg, designed explicitly to process complex, low-grade strategic materials and smelting intermediates at a massive industrial capacity. The strategic implications are immediate. Consolidating North American power, Metalor secured full regulatory approval for its acquisition of Gannon and Scott, locking down major secondary precious metal refining pathways and absorbing massive industrial scrap volumes across the United States. Despite these breakthroughs, the contrast is stark. Traditional players like Boliden continue to produce high-grade primary silver products for global electronics, but they are hitting a physical wall. Ore grades at major primary deposits have plummeted by over 50% in the last decade, rendering traditional extraction economically and environmentally unsustainable against surging demand. Without closed-loop metals, AI and EV hardware will starve. Heraeus and Sibanye-Stillwater target difficult alloy separations, while Johnson Matthey uses hydrometallurgical processing to dissolve e-waste into ultra-pure elements without slag. Commercial scaling hits reality. Aurubis launched a plant cutting 8,500 tons of carbon and a Hamburg exhaust capturing residual metal. This silver drives unorthodox adoption. Heraeus AGXX uses it for antimicrobial surfaces, eradicating 130 bacterial species. The smoking gun? Mitsubishi Materials proved secondary yields hit parity. Scaling this, NTT and Mitsubishi formed NTT Circurust to recover IT infrastructure and track recycled materials. Geopolitically, ReElement and Mitsubishi partnered to secure localized allied supply chains, ensuring the critical silver required for the green infrastructure of tomorrow is never reliant on the destructive extraction methods of yesterday. This is the turning point. Next Move Strategy Consulting projects the global silver recycling market will reach $17.57 billion by 2035 at a 4.51% CAGR. This data sets the trajectory. Companies owning physical recycling infrastructure will fundamentally dominate the next decade. They aren't just processing waste, they are mining the urban landscape and controlling the closed-loop supply chain. We are no longer digging deeper. Every discarded circuit board and solar panel is now an active mine. Looking for deeper data and market forecasts? Explore the full report through the link in the description. If you found this breakdown valuable, make sure to subscribe to stay ahead of the curve. We'll see you in the next analysis.